Okay, good afternoon. So today's lecture, we will start, or we will continue on what we started last lecture, which is basically, we used to say about the canonical form, which is there is a forward and feedback. And in that, if we see any transfer function or any block diagram, if we need to write it in the canonical form, we need to make it, to simplify it into this formula. So in this canonical form, we realize that there's a feedback, feed forward, inputs, outputs, there is the error ratio and actuating ratio, etc. The overall closed loop transfer function will be the forward divided by 1 plus minus, which is the opposite, the sign of the feedback, forward times feedback. And the characteristic equation, which is basically look at the closed loop transfer function and so the denominator. The denominator equals 0. This is the characteristic equation. Let's look at this example. Assume you have this transfer function or this block diagram, which is already written on canonical form. Then from this canonical form, we need to find these 7 requirements. The first thing, open loop transfer function. Basically, the question in the original question, this shouldn't be written. You need to realize it by yourself, okay? These in yellows are not written. You need to realize it by yourself. So the open loop transfer function. The open loop transfer function, basically, it is, look at this and make it as a loop, complete a loop, which is G times H, right? Make it a loop, which is Z times H. Therefore, G times H, which we realize it will be as 0.1 times K divided by 1 plus K times S plus 1. Okay? This is the open loop transfer function. Or in other words, some people or some references say this is B of S, this is E of S, R of S, C of S. So it can be, we can say it as C of S over, or not C, actually B of S over E of S. So which is yields these two. You don't need to memorize what's this. The thing which is you need to figure out how to find it, okay? This is in page, I think, do you know what's the page number? I did have the numbers here. 12, page 12. So, okay, the next thing, the feed forward transfer function. The feed forward, basically, which is related to where only the forward path. This one, right? Understood? Okay, so the feed forward direct, it is what? G of S, which is K divided by 1 plus K times S plus 1. The next thing, the control ratio. The control ratio, which is basically C of S over R of S. Or in other words, the closed loop transfer function. And the closed loop transfer function, which is what? G over 1, since here is negative, it will be positive, right? G plus 1 times GH. I'm sorry, G divided by 1 plus GH. Then, in other words, we can simplify it. I'm going to simplify it here, number 3, which is G of S divided by 1 plus GH. And let's substitute it. It will be K divided, or K over 1 plus K S plus 1 divided by 1 plus 0.1 K over 1 plus K times S plus 1. Now, since it's written in this format, I need to simplify it to be a denominator and numerator and denominator. So what I need to do, look at the common factor here. I need to make the coefficient of this one as 1. So what I will do is basically, I'm going to multiply by 1 plus K S plus 1 divided by 1 plus K S plus 1. This yields what? This one will cancel this one, and this one will cancel this one, but we'll multiply it here. Therefore, I can write it as, here's continue number 3, which is K divided by 1 plus K S plus 1. plus 1, then there's another one which is plus 0.1k. Okay? So you need to know how to simplify this in the right way. One of the common mistakes in the previous semesters, many people, they're doing this correct, but they didn't know how to get this results. They didn't know how to do the simplification. So you need to be aware, and how can I do the simplification? By multiplying by the common factor, okay? Look at the denominator, this common factor, we will multiply this one by this one, and that's it. So this is number 3, which is the control ratio. Then the next one, the error ratio. The error ratio, basically, when you look at it, here is the error, here is the inputs. Then from error perspectives, the feed-forward gain is 1. Go from here, from R of S, toward E of S. What's the feed-forward gain? 1. Like this. What's the forward gain? My output is E of S. So the feed-forward gain is 1. The number or unity, it's 1. How about the feedback? G of S and H of S, they are now, both of them are feedback. Okay? Again, why? My observation point right now, it's no longer C of S. My output, or the observation point, treats E of S as the output. So E of S, when you look at it, it can be written as shown here. We can write it as, this is E of S. Here is plus minus. Here is G, and here is H. This is how it looks like. You see it? This is how it looks like if you look at E of S as an output. Therefore, the feed-forward gain is 1. The feedback is GH. Right? Does this make sense? Okay, that's great. Now, in this part, since E of S over R of S, it will be the forward, which is 1, divided by 1 plus the opposite sign, forward, which is 1, times GH. All good?
So G and H have the
G and H, both of them right now, they are the feedback. Exactly. Okay. Now the next thing is, or how can I substitute it? Let's substitute 1 divided by 1 plus GH, which is 0.1 K over 1 plus K times S plus 1. So what should I do to simplify it? What do you think?
multiplied by
1 plus K S plus 1 divided by 1 plus K S plus 1. So this yields this, I will write it here. 1 plus K times S plus 1 divided by 1 plus K S plus 1 plus 0.1K. Okay? This is E of S over V of S. You need to know these math. How to do the simplification is a must. When you look at this, what's the type of this function? Is it strictly proper, biproper, improper? What do you think? Biproper, because the order is first order, the second one is first order. How about the rank, or what's the type of this? First order, exactly. That's great. Now the next thing. No? Yeah, this is number 4. Oh, I forgot this. Okay, I talked about number 1. Okay, number 4. Okay, now we did so far. We did number 1, 2, 3, 5, and now we missed 4. Let's do number 4, which is the feedback ratio. Feedback ratio, basically, we will treat it as B of S over R of S. That's that we are how we treat it. Therefore, when you look at it, you will realize G and H, both of them are what? Forward. Because my output or observation is B of S. I can redraw the block diagram here, then you can see how it looks like. Here is R of S. Here is E of S. Then What do we have here? We have G, then we have H, then we have B of S. This is how we can imagine it, okay? Then by looking at this, you will realize we need to find B of S over R of S. What's the forward gain? GH. How about the feedback? 1, or unity feedback. Therefore, what we can say is B of S over R of S, it is actually GH divided by 1 plus GH. Okay, does it make sense? Now, let me substitute them, which is 0.1 K divided by 1 plus K S plus 1 divided by 1 plus 0.1 K over 1 K times S plus 1. Then I need to modify or simplify it by what? Look at the common factor. 1 plus K times S plus 1 over 1 plus K times S plus 1. This yields to be 0.1 K because this one and this one cancel each other. This one goes here and here. 0.1 K divided by 1 plus K S plus 1 plus 0.1 K. Okay, all good? That's great. Then this is B of S over R of S, which is this number 4. Now we did number 4. The next thing, the closed loop transfer function, C of S over R of S. We already did this before. 6 and 3, they are exactly the same. C of S over R of S. Then it's all right. The next thing, the characteristic equation. The characteristic equation, basically, recall that characteristic equation. Look at the closed loop transfer function. The closed loop transfer function, it was, where is it? This is the closed loop transfer function. K over 1 plus K, S plus 1 plus 0.1 K. This is closed loop transfer function. Then to find the characteristic equation, basically look at the denominator or the maqam. So make the denominator equal 0. Therefore, this yields 1 plus K, this is number 6. 1 plus K times S plus 1 plus 0.1 K equal to 0. Okay. Then this is the characteristic equation. We will stop here for the characteristic equation. There's nothing else we can do. The next thing, this is number 7, actually, number 6, whatever. Number 7. The next thing, to find the closed loop poles and zeros if we assume K equal 10. So in number 8, let me write the closed loop transfer function, which is C of S over R of S. It was, we've already K divided by 1, what is called 1 plus KS. 1 plus K times S plus 1 plus 0.1 K. Now we need to find the poles and zeros. Assume K equal 10. Now let's substitute them as, which is 10 divided by 1 plus 10, 11S. 1 plus 0.1 times 10, which is 1. So 1 plus 1, 2. Okay. Now we need to find the poles and zeros. Is there any zeros? None. How about poles? 11S plus 2 equals 0. Therefore, S equal what? Negative 2 over 11. How about pole zero mapping? Negative 2 over 11. How about the stability? Stable. Exactly. Which is bounded input, bounded output stable. Or you would say stable. No problem. You don't need to write people stable. You can say stable. That's fine. Maybe in the future courses, you need to distinguish it's bounded input, bounded output stable or internal stable, which is not part of our topic right now. Now, we know, based on the canonical form, how to find all of these 9 unknowns, I think, or 8 unknowns, which is great. Now we know everything, how to find this. The next thing, how about if the block diagram is not written into this way? I need to simplify it to be written like this. How can I simplify it? We will study it right now. My target, the next thing, is to either to convert the block diagram, no matter how complicated, to be into canonical form or closed loop transfer function. Okay? Let's try to make our goal one of these two. That's the thing. Here's an example. Some reduction techniques or combination techniques. Whenever we have something like that, G1 and G2 here, you can combine them, G1 times G2, okay? These are in series, then you can combine them as multiplication. If we have parallel, then there's plus plus, therefore G1 plus G2. If there is any subtraction sign for some reason, let's assume this one is negative, not positive, therefore it will be G1 minus G2. Okay? That's all. So it's already well known, but we would like to make it as a rule. Let's try to make them as some governing rule, then we'll try to simplify it and apply this in an examples. I mean, you're already aware of this, but we will do it step by step. Now, there's some other reduction techniques, which is moving a summing points behind a block. Basically, sometimes you can have the summing points here, and for some reason, you need to change it to go here, like what we have here. If you need to change it, you can keep in mind that this is G of S. It will be multiplied here, G of S here, and G of S here. And that's what we did. How can I prove this one equal to this one? Basically, you can say here is the error. The error is actually x1 minus x2, whatever it is. Here, x3, which is G times what's the error. Or in other words, it will be G times x1 minus x2. Or in other words, it will be G times x1 minus G times x2. And that's what we did here. Gx1, Gx2. Okay? This is the proof. Then, in this situation, you can take it as a rule. Whenever we are moving the summing points after a block, don't forget to multiply it here and here. Okay? It's just addition. Why I need to do this? We will see it later. Here, I'm trying just to teach you some toolbox. It's like a toolbox you have. Then you will use the tool whenever you need it. If you don't need it, just keep it. Okay? Put it just inside the box. Moving a summing points ahead of a block. Now assume the opposite. Here, the summing block, it was in the back, we are moving it forward. Now it is forward, we move it back. We will move it here. So if we need to move it here, when we move it forward, what we did, we multiplied by G here, and we multiplied by G here, right? However, if we need to move it back, we need to what? Divide both sides. So we will divide this side by 1 over G, this side by 1 over G. Therefore, 1 over G and G will cancel each other. This is 1 over G here. Okay? Again, when we are moving this forward, it will be multiplied. When we move back, divide. So we will move it back here. This yields divide both parts, 1 over G, while this part will be G. So this part is G, this part is 1 over G, and this part G and 1 over G will cancel each other. Understood? That's great. Now, how about the pickoff points? We know what's the pickoff point, right? Last lecture, we already mentioned this. So the pickoff points, assume that you need to move the pickoff points from here to here. So which is basically moving it forward. If we are moving it forward, basically, it will be the opposite of the summing points. Basically, we will put G here and 1 over G, 1 over G. Okay? Because the summing points, when we move the summing points ahead, move it forward, what we used to do, multiply. And here, I think, it's the same, right? No, we're moving it backwards, right? Which is the same thing. Okay, again, we will move this back, then we will divide 1 over g. Here, 1 over g, and g, 1 over g will cancel each other here. Oh, I'm sorry. Let me do it again. We will move this back. When we move this back, this will be here, and this one will be 1 over g, and 1 over g here. G and g cancel each other. Okay, that's the thing. Then, if we want to move it ahead from here to here, basically, we will multiply by g this part, and this part has already been moving here, or 1 over g and 1 over g will cancel each other. Anyway, I don't want to avoid the confusion to you. So when we are moving it forward, move it backward, we'll divide this by 1 over g. When we are moving it forward, we'll multiply this part by g. That's the thing. In summary, the last 4, when you have the summing points, that you need to move the summing points forward, moving the summing point itself forward, this yields what? G here and g this part. If you are moving it backward, it will be 1 over g in this part. Then the same thing here, moving the point here, it will be 1 over g, while moving it backward, it will be g, which is kind of the opposite. The next thing, the feedback, eliminating the feedback loop. So as we know, for the feedback, the closed loop transfer function formula, like even in the canonical form, forward, divide by 1, the opposite sign of this part, times forward and feedback. Keep in mind just the opposite sign. It's a very famous formula that we used it more than 100 times. So anyway, I would say that keep in mind the sign, okay? The opposite direction of the sign. This one, the second one, there is no feedback, or it's actually unity feedback. We'll say it is unity feedback. And this is very important. We will use its unity feedback information. We will use it maybe next week or the week after next week. If it is unity feedback, we will treat it as something special. It will be a special case than the original one. So we can say any closed loop or any block diagram, the canonical form is treated special. And the same thing inside the canonical form, if it has a unity feedback, it will be treated also as special. Okay? That's the thing. Yeah, the unity feedback, there is no H, or actually the H is 1, which is a straight line. It's a unity feedback. How can I use it, or what's the importance of it? We will talk about it once we reach it, so in the future chapters. Again, it's the same, it's closed loop formula. G over 1 plus minus, which is the opposite sign, GH. But keep in mind, H is 1, therefore it will be G over 1 plus minus G. Okay, all good? Number 7, which is swap 2 neighbor summing points. If when you look at the summing points, here is B, here is A, and the same signs, plus minus, there is no problem in swapping A and B. If you switch them, like here, there is no problem in that. Because there is no multiplication, it's just only summing, okay? So it looks like when you say X plus Y plus Z, if you make X plus Y like this way, or if you say X plus Y plus Z, if you do it this way, both of them are correct. So there is no problem in swapping this. Okay, again, closed loop transfer function in canonical form. This is canonical form. It is extremely important. In signals and systems class, it was very important. And here it's super important. Okay, G over 1 plus GH, why it is plus, why it's positive? What's the point? Why it's not negative? Because negative feedback, again, the opposite sign. Okay, I don't want to see this mistake in the exam or in the quizzes or not the exams or the homeworks, whatever it is. I don't want to see this because I already warned you many times, and I will not be tolerated in that. Block diagram reduction. Now that goal here is try to convert this block diagram, the first thing to canonical form, the second thing to the third or to the closed loop transfer function. Now with this block diagram, let me see. Do we need to do it? Here I'm going to do it as a closed loop, not as. My goal is to make it to find closed loop transfer function, not the canonical one. The closed loop. Make. We need to find y of s over r of s. Okay, so how can I do it? Start with the simplest way for you. Is there a combination of summing two together, multiplying two together, or adding two together? Oh, there is nothing. Is there a way to do a closed loop? Can I do a closed loop into this one? Unfortunately, no, because there is this one will ruin it. Or no, not this one, because we have summing here and summing here. There must be only one summing. Okay, so I cannot. Yeah. Can I do a closed loop here? Oh, there is one branch going up. This one will ruin it. Because when you do the closed loop, this node will disappear, right? When you do the closed loop, this node will disappear, correct? If it disappears, where should I connect H2? Where? I don't know. Okay, let's. How about closed loop with H3? If you do a closed loop here, you cannot because there are some other branches here and here. Okay. Leave it like this, right? I can do nothing. No, here's the trick. Let's try to learn the 8 rules that we learned here. I think there were 7 rules. Yeah, let's try to think about this. Move big points. If we move this point from here to here, what will happen? I mean, yeah, but let's think about it. Will this make sense for me if I put it like this? If I put it like this, what's going on? I can make these two together, right? I can do a closed loop here, right? Because this point still exists. So the key goal or the target of this point from here to here. So when we are moving it from here to here, we will divide this branch by 1 over g. نضربها ولا نقسمها؟ Move this point. Moving g to the back. Let's go back and see. So g, it was here. It will be go. No, it was here, right? Or it's actually here. It's number 4. We are on number 4, which is g is located here. We will move it here. So it will be g will remain here, divide 1 over g. So we will divide by g4. So when we move it from this to here, we will divide by g4, 1 over g4. Okay? Again, we will move this pick of points from here to here. Then we are moving it. I can erase this, connect this here, but connecting this is not enough. We will multiply 1 over g4. That's according to rule number 4. Let me erase it. Then move forward. Then you see, we're already moving it here, and we already divided by g, divide by 4. Correct? That's what we did. Do you agree with me? Now, the next thing is try to do more reductions. So let's look at the orange circle. What we can see that G3 and G4, they can be together, right? They are. After that, look at the green circle. They are a closed loop, correct? So what we can say is in the green circle, it will be G3 times G4 divided by 1 plus 1 minus, because why? Negative. Exactly. Times G3, G4, H1. Okay? Now the next thing, redraw the circuits or redraw the block diagram and see, is there any other observations? That's what I did here, the simplification. Now look at this. Is there any extra simplification?
G2.
Yeah, there is, which is basically a closed loop here going on in the orange circle. So what we can say, the forward, G3, G4, 1 plus minus G3, G4, H1, they are forward, while this one is the feedback, okay? So the closed loop transfer function can be written as G2, G3, G4 divided by 1 minus G3, G4, H1 divided by 1 plus or minus? Plus, because the opposite sign. G2, G3, G4 divided by 1 minus G3, G4, H1 times what? H2 over G4. Now, I need to simplify the look at the denominator and the numerator. What's the common factor here? 1 minus G3, G4, H1. Do you think this is enough? There is a G4 as well. Uh-oh. Somebody's trying to call me. I'm sorry. Let me go back. Divided by, come on. Okay. What's wrong with them? Okay, let's wait. No, because somebody called me and it made all of this because it already saved this into the cloud and now it's downloading it from the cloud again. And we know in Jordan we have a slow connection, internet connection. So now, why I multiply by G4? Because we have a G4 here, G4. Okay, so that's why we will multiply by this part. Then divide by G4, 1 minus G3, G4, H1. Then when we do the simplification, it will be like this. Okay? Okay. Now, simplify it more. Like what? Canonical form, or actually closed loop transfer function, right? Yes. So we will say G1 times G2, G3, G4 divided by 1 minus G3, G4, H1 plus G2, G3, H2 divided by 1 plus H3, G1, H3, this one. G1, then that big term. This big term. Okay? Then we need to simplify it by multiplying denominator and numerator by this term. Then the overall will be like this. I mean, I don't want to spend too much time on it. That's how it will be. So the trick here is the math. You need to know how to multiply and how to divide. Okay? Any question? The next thing, we need to reduce this into canonical form. Now it's not closed loop. We need to make it as canonical form. What does canonical form mean? Let me go back a few slides. like this. Make it like this. How can I do it? G1, G4, they are together, right? Then after that, with H1, closed loop, right? So G1, G4 with, and there's another thing that they said, G3 and G2, they can be combined together. Then G1, G4 and the H1, they are a closed loop, right? G1, G4 over 1, since it's positive, makes it negative. Then G1, G4 times H1. Okay. Then by redrawing the block diagram, this is the new block diagram. This is how it looks like. Now we need to simplify it more. We can say these two together, and this one is a feedback. Therefore, we can say the closed loop. Oh, actually, we need to make it canonical form. I apologize. Canonical form makes these two. Identify the closed loop. Makes these two. So it will be G1, G4, and G3. That's what we have. This has already been written in what? The canonical form. So the first requirement, find the canonical form, I'm done with it. That's it. The next thing, from this canonical form, is it the same example? No, it's a different example. But I would say if we need to find closed loop transfer function, we know how to find it, right? If we need to find the open loop transfer function, the error transfer function, like C of S over R of S, or E of S over R of S, or B of S over R of S. You know how to find this, right? The other thing, C of S over B of S. This is B of S. No, this is E of S. E of S. B of S. Okay? You know how to find all of these. We already did it in example number 4. Now, example number 6. Look at this block diagram, and we need to find these requirements. Open loop transfer function, feed forward transfer function, control ratio, feedback ratio, error ratio, closed loop transfer function, characteristic equation, closed loop, false and zeros. This is a good example of an exam question. And I think in the first exam, mid-exam last semester, that was one of the exam questions. How to find this? Let's assume that you already have this in the exam. Then what we need to do is find open loop transfer function, feed forward, etc. Keep in mind, before doing anything at all, convert this to canonical form. Okay, is it in canonical form? No, it's almost in the canonical form. The thing which is, we have this loop that prevents this from being canonical form. So what we need to do is to do this loop. So it will be K over S plus 1 divided by 1 plus K over S plus 1 times S, right? And the common factor here is S plus 1, right? S plus 1 over S plus 1. This yields the transfer function to be K over 1 plus, or S plus 1 actually. S plus 1 plus KS. Take S as a factor in the denominator. This yields K over 1 plus KS plus 1. Correct? Where? Here's S plus 1 plus KS. Take S as a factor. So this one and this one will be 1 plus K. And this one will go here, right? Now, the transfer function no, not you. Yeah, move this.
There's two sum points in same rate and some like one.
I mean, you can swap between these. So you can make this one goes here and this one goes here. But I think this will complicate.
Some of these, like, they have the same operation.
So you would like to make closed loop here into this part and leave us. That's fine. Switch them, swap them, okay? You can swap them and you can do that. There's no worries with that. In this situation, you will have kind of different answers, but it should be fine. There's no problem. But as a closed loop perspectives. So anyway, I can redraw the closed loop block diagram to be 1 plus k times s plus 1. Here, c of s. Here is 0.1 subtraction plus r of s, and that's it. And we can say here is the error e of s, here is b of s. Now, is it in canonical form? Yes, so I'm ready to find these 8 unknowns. What's the open loop transfer function? What do you think the open loop is? What? This one times this one, open loop. Loop transfer function. This one. So it will be what? 0.1 times k over 1 plus k s plus 1. That's it. We're done. Number 2.
Feed forward.
Feed forward.
K plus 1 over k s plus 1.
Exactly. Number 3 is what? Control ratio, which is the same as the transfer function, c of s over r of s. Then it will be what? K over 1 plus k s plus 1 divided by 1 plus 0.1 k over 1 plus k s plus 1. Then multiply this by 1 plus k s plus 1 divided by 1 plus k s plus 1. This yields the transfer function to be as k divided by 1 plus k s plus 1 plus 0.k. Okay? This is the closed loop transfer function. The next thing, number 4, feedback ratio. Feedback ratio, number 4, which is b of s over r of s. Then it will be something very similar to what we have here, but it will be like 0.1 times k, because both of them in the form feedback, those are forward, and the feedback is 1. We already discussed this before. So it will be 0.1 k divided by 1 plus k s plus 1 divided by 1 plus 0.1 k over 1 plus k s plus 1. So what we can do is 1 plus k s plus 1 divided by 1 plus k s plus 1. This yields the overall transfer function, or the overall feedback transfer function, to be as 0.1 k divided by 1 plus k s plus 1 plus 0.1 k. Okay, this is number 4. Tamam? Number 5, error ratio. Number 5, error ratio means E of s over R of s. Now here the situation is different. In E of s, there is unity feed forward, and the feedback is these two, right? Now it can be written, where is it here? 1 over 1 plus 0.1 k divided by 1 plus k times s plus 1, which is what's after the simplification, 1 plus k plus 1 plus ks plus 1 divided by 1 plus k times s plus 1 plus 0.1 k. Okay? This is number 5. Okay, number 6. Number 6 is what?
Closed loop transfer function.
Closed loop transfer function, which is the same as number 3. So number 6 and number 3.
The denominator equals to first.
Which was number 7. Yeah, let's talk. This is number 6. Now the number 7 to find the characteristic equation. So the characteristic equation. Let me rewrite the closed loop transfer function. That was k over 1 plus k s plus 1 plus 0.1 k, and this, the denominator, this one, make this one equal to 0. Therefore, this yields the characteristic equation to be as 1 plus k plus 1, here is times s plus 1, 0.1 k equals 0. This is the characteristic equation. Okay? And the last thing, assume k equal 10. Then if k equal 10, this yield the closed loop transfer function. This is C of s over R of s. This will be as 10 divided by 11s plus 2. Then how about the poles and zeros? No zeros. There is one pole at s equal -2 over 11. Okay? Now we are an expert, right? We know how to find the closed loop, error ratio, control ratio, feedback ratio, open loop transfer function, open loop transfer function, or loop transfer function, G times H. That's it. Okay? Please, you need to distinguish. I don't want you to get confused when I say find the loop transfer function or open loop transfer function. I don't want to see a closed loop transfer function. Okay? Here is the answer in details. It's already been written here. Okay. There's an example, number 7. It's very similar to number 6, and this is a homework. Okay? Yep. Due by today is Monday. I would say Tuesday, because Monday will be the graduation day, right? Yeah, and 28th, July 28th will be graduation day. So let me say due by Tuesday. Okay. They're most likely Monday, I'm not sure, but there might not be a class on Monday. I will let you know. But it will be by Tuesday 29, July 29. Okay? Please make sure to bring it. When you bring the homework, I want the first page will be cover page. First page will be the cover page. Nothing else written on it, it's just cover page. Then, second page or page 2, do the answer, do your job. Okay? So I want a cover page in the homework, is a must. And the homework will not only be example number 7. Let me show you the overall homework. Will be example number 7. And I think we will back to it. It will be on example number 10, number 11. Come on, 12, 11, 12, 10, 11, 12. There will be 4 problems. Okay? Yep. Yes. Number 7 is the only problem that you need to find the 8 unknowns. Number 10, 11, 12, find the closed loop transfer function. Okay? So number 12, 11, 10, find the closed loop transfer function. However, number 7, and number 7, where is it? You need to find these 8 unknowns, okay? Again, the homework for problems. Let me write it. Example 7 that has 8 unknowns, 8 requirements. Example 10, example 11, example 12, all of these closed loop transfer function. And keep in mind the first page must be the cover page. Yep. Your name, homework number 1, the name of the course, the semester, etc. Just a cover, the regular cover page. Then, second page, start your problem. And keep in mind, I want a separate page for each example. So let's assume example number 7 took you 2 pages, okay, or 1.5. Don't start from the second page, example number 2. No. Example number 10 will be the next page. Okay. Separate it. Yeah, make it separate pages. Okay. Say that again.
I said the example.
Yeah. Yeah, each example has its own pages. Let's assume example 7 take 1.5 pages, make it as 2 pages. Then example number 10 will be in the separate page. So every example will start in its separated page. I don't want to see the end of example 7, then example 10 in the same page. No. Or let's assume example 10 is short and example 11 in the same page. No, make it separated pages. Okay? cover page تكتب فيها الاسم واسم المساق زي كفر بيج اللي متعودين عليها، بس بدها تكون لحالها، ما تكتب عليها الامثله والحل. بعديها كل مثال له صفحته. يعني مثال رقم 7 له صفحته، مثال رقم 10 له صفحته، له صفحه خاصه فيه. لو نفترض مثال رقم 7 طلع طويل اخذ لك صفحه ونص، ما تكتب على النص اللي ظل مثال رقم 10، اعمل صفحه جديده. تمام، نقطه وسطر جديد، بتبلش عفوا صفحه جديده وبتبلش مثال جديد. تمام، نقطه وصفحه جديده. ايوه، نقطه وصفحه جديده، مش صفحه. اتفقنا على الهوم وورك. اللي مش ملتزم بكفر بيج مش ملتزم كل واحد له صفحه، راح يتحاسب الهوم وورك من 7 مش من 10، حتى لو حلك 100% صح، عشان نكون على اتفاق. يعني هذول عليهم 3 علامات، اذا التزمت باللي حكيت لك اياه عليهم 3 علامات. حتى لو حلك غلط تاخذ 3 من 10. اذا عملت كفر بيج وكل واحد صفحه حلك غلط تاخذ 3 من 10. هايك على اتفاق. فاذا التزمت بالتنسيق اضمن 3 علامات، بضل 7 علامات على التكنيكال كونتنت. هاي اول نقطه. النقطه الثانيه لازم نحل كله. النقطه الثالثه ما في ديت، فالتسليم راح يكون يوم ايش؟ ثلاثاء. اذا بدك تسلم اربعاء راح يتحسب من 5. تمام. واذا ما كنتوش حاطين كفر بيج بتشيل ال3 علامات بتصفي ايش؟ المهم ذاتس ذا ثينج. اوكي، هنا احنا خلينا نكون متفقين قبل ما يقع الفاس والراس. تمام. فبالتالي الليت اذا كان في حدا ليت راح يتحاسب من 5. اذا شفت حالك مش قادر تحضر المحاضره اعطينا زميل خليه يسلمه عنك. تمام. ما في الكترونيك سبمشن، ما في وديت لك اياه على التيمز دبر حالك، ما فيش. او وديت لك اياه تودي لي اياه ورقي، بدي اياه مطبوع، مش مطبوع مكتوب، بلاش مطبوع، بدك اياه ورق خط الايد ما في مشكله، ورق بدي ورق يكون مسلم. وبرضه ممكن احاسب شغله عليها يكون عليها علامه، لازم يكون نيت ريبورتس. تقرير يليق بمهندس. تمام، تقرير يليق بمهندس. كيف يعني؟ يعني تكتب لي اياه بدون نفس. it's not neat. عليه علامه نيت ريبورت. تمام، يعني ممكن حلك صح تجي 9 انه مش نيت. تمام، نيت امور ديل. اوكي، بس هاي العلامه مش من ال10، يعني هاي العلامه تخصم، يعني يا بتخصم يا لا، بس penalty. So again, no late homeworks. If you're gonna submit it on Wednesday, there will be one. It will be counted out of 5. After that, 0. I will not accept any late. The other thing, which is keep in mind to try your best to solve it for your reference and take a picture, take a photo, keep it for your record, because I might not return it to you before the mid exam. So you need to have a copy of your answer. Okay? Okay. Again, if there is no cover page, it will be awful. And my point of view, don't use, for example, don't use this paper, okay? It's not neat. Use A4, okay? Use white paper, the white paper. Don't use this. Don't make a cover page using this. This is not neat. Definitely, if you are using this, I will take 1 point, even if your answer is correct. You will take maybe 9 out of 10 because using this kind of paper. Okay? استخدم فول سكاب ورق ابيض مش مشكله بس ما تستخدم هذا الورق الممزوع من الدفتر. Deal? Let's continue. Yep. We need to continue. Here is example number 8. Come on. Yeah, we still have 10 minutes left. That's fine. Whatever here. We need to solve this. Now the challenge is. That's what we did. Move G1 from here to here. When we move it to here, it is basically we will put it here and divide by 1 over G. And that's what we did. We move the summing points and we divide by G. The next thing is G1 and G2 can be combined together. Okay. Then what else? H2 over G1 what? How about G3? Moving G3 here. Can I move it? Yes, I can.
H1 over G3.
G3. Actually, when we move it here, this will be multiplied by G3, and this one will be divide 1 over G3, or multiplied. I think multiplied by G3 because I'm moving it here. H. Did we move it or no? We swapped these two. Okay, no problem. There is no problem. If you don't want to do this, what we did, the next thing, swap these summing points so we can do a feedback. Here. Swap it, then we can do a feedback here. Then when we do the feedback, G1 times G2 over 1 minus G1 times G2 times H. That's the next thing. G3 is multiplied by all of this. Okay. After that, there is a closed loop here, right? Let me call this one as C1, or let me call it as X, whatever. X1, this is as X2. So it will be X1 divided by 1 plus X1, X2, right? Then it will be combined like this. After that, it's a single loop with unity feedback. Therefore, if we assume this as X, it will be X divided by 1 plus X, right? Yeah, there's no problem. Yeah, if you do this assumption, but don't stop it like this. Substitute the values. This is for your simplification. Then you will write G1, G2, G3 divided by 1 minus G1, G2, H1 plus G2, G3, H2. Okay? Then divide by 1 plus G1, G2, G3, 1 minus G1, G2, H1 plus G2, G3, H2. When you do this, like, for example, let's assume you are in the exam or whatever you have, and you didn't have enough time. Leave it like this. You will back to it after you finish the whole exam. Okay? Then you can simplify it. In case if you are after running out of time. It's fine, but you need to make it in the simplest formula like this. But I would say the weight of this is very low. Or sometimes, if the exact time is very short, then I might consider this as correct without taking any points. Okay. Now, number 9. Number 9, because 10 is what? 10 is homework. So we will finish 9 and see. Come on. Number 9. Find the transfer function of the following block diagram. Where is it? Number 9? Let's see. Let's think about this. That's fine. Number 9, one of the things is to move Come on. This point from here to here. Okay? Okay, move this point from here to here. Move it from here to here. This yields G2 and multiplied by G2. After that, from this simplification, new simplification, you realize that G2 and G3 are summed or multiplied by each other, and they are summed with G4. Okay? And H1, G2, H1 can be grouped together. Then from this part, we can move the summing point from B to this point, from here to here. Then when we move in it from here to here, we will divide by 1 over G for G2, G3, divided. Then we can group this loop, G4, G2, G3, and H2 can be grouped together to be like this. Then with this one, this can be combined, multiplied by each other. Then the overall can be grouped together. Okay? I don't want to spend too much time on the calculation. It just we know how to do of this calculation. Then here, it's a unity feedback, and that's it. This is example 10, homework 11, 12. Now, tomorrow's lecture, we will go on example number 8. That's the thing. Let me stop the recording, and I need to talk to you just a little.